Hey everyone, Mr. Anderson here again with you for another exciting edition in geometry. All right, hey, good news is we're not talking about lines crossing parallel lines anymore. Today we're going to talk about triangles. Okay, so we're in chapter 4, section 1. We're going to talk about classifying triangles today. All right, first of all, our objectives: identify and classify triangles by angle measures, and then identify and classify triangles by side measures. All right, so first of all, in this situation here, we've got ourselves a triangle over here, right? Here's triangle ABC. Again, remember how we would draw the little triangle symbol ABC. So here's our triangle ABC. What are the sides of this triangle? So remember, the sides are just the line segments. So we've got side AB. So AB, remember, line segment AB. We've got B to C, right? So line segment BC. And we also have from C to A, line segment CA. Okay, so remember, those are our different sides. They're just line segments. The vertices, do you remember vertices, what we called those? The vertices are the kind of the points here, okay, where the two line segments come together. That would be a vertex. Vertices is plural. And so we could say point A, point B, and point C are the vertices. And then the angles, remember, there are three angles. There's this angle, and this angle. In this case, we could call them just by one letter, but to get you used to seeing it with three letters, I'm going to name it with three. So this angle here, I'm going to do this. I'm going to call that angle 1 there, which I'm going to call angle CAB. Okay, CAB. You could also call that BAC. In this case, since there's no other angle A's, you could just call it angle A, but I want to get used to seeing these. All right, then angle 2 is this one here, and I'm going to call that one angle ABC. Again, you have to go in order. A, and then the vertex is going to be your middle letter there, and C would be the other side. So notice the vertex on angle CAB is A. On ABC, the vertex is B. And in this case, then angle 3, I'm going to call that angle BCA. Okay, so just a little review about the triangles and kind of what goes into them. Okay, so all right, so we're going to classify triangles by their angles. As you can see here, handy dandy little chart. You've probably seen this before. Basically, here's what it boils down to is, if you have, I'm going to start here on the far right over here. If you have a triangle that has a right angle in it, no matter what else is happening there, if it has a right angle in it, it's called a right triangle. Okay? If you have a triangle where one of the angles, in this case, this angle right here, is bigger than 90, it's going to be obtuse, an obtuse triangle. It has one obtuse angle. I'm going to jump over here to acute. Acute would be if you have three acute angles. So three angles that are less than 90. All three of these would be less than 90, would be acute. Now there is one extra thing here, this equiangular triangle. And that's when all of the angles are the same, which it doesn't say it here, but these would all be, in a triangle, they would all be 60. Okay, so that'd all be 60 degrees. Notice, 60, 60, 60. Those are all less than 90. So technically, this is an acute triangle as well, but if we have an acute triangle where all three angles are 60, we're going to be more precise than just calling it acute. We're going to call it equiangular. Okay, so even though, yes, this is acute, we want to call this special situation, we want to call it equiangular if it's got three 60-degree angles there. Okay? All right, so let's take a look and see what we got here. All right, classify the triangle as acute, equiangular, obtuse, or right. All right, so if you look at this, what do we got? 60, 60, 60. Hey, those are all the same, aren't they? What do we call it when they're all the same? We call it equiangular. Equiangular, okay? It's kind of a weird word, I know. Equiangular. But it's fun to say if you can say it. All right, next. What about this one? Look at the three angles. We've got 20, 30, and 130. Okay, well, We know it's not equiangular because they all have to be 60. We just did that one. If you look, see what's left. Acute means they're all less than 90. Well, we got less than 90, less than 90. Oh, wait a minute, that's bigger than 90. So that means it's got to be obtuse. Okay, so that is an obtuse triangle. Oh, fun. Okay, multiple choice. All right, well, let's take a look at this. It says the frame of this window design is made up of many triangles. So there's a lot of different triangles in here. Classify ACD. Okay, so this is triangle ACD. So ACD is this one right here. So from A to C to D. Okay, so that's the triangle that we're talking about right in here. So this is the one. I'll put a little X in there. All right, that's the triangle that we're talking about there. Is it acute, equiangular, obtuse, or right? Now, there's not any measurements in here, so we kind of have to like just go by what it looks like. All right, so first of all, do you see any right angles in here? Does this look like a right angle? Does that? Nope. Equiangular means they're all the same. Do they all look like they're the same? Nope. So what's left is acute and obtuse. Well, that looks like less than 90. That does, but that looks like more than 90. Angle C there, ACD. So we're going to say C, obtuse. Let's look for the bouncing red circle, and it says C. Okay, good. Obtuse. That's an obtuse triangle. How about this one? Now, in this case, we're looking for ADE. So ADE is this big triangle here. Okay, so it's this one. Kind of looks like that. It's that big one there. All right, what do you think? Take a look at that. Okay, this angle, this whole angle here, and that angle. Well, they don't look the same, so they're not equiangular. Any of those look like they're bigger than 90? Not really. The question is, what about this one down in the corner here? Well, to me, that looks like that's 90 degrees, and so it looks like it's right. And red bouncy ball says it's a right triangle. Good, okay. Sometimes you might have a more complicated situation like this. This is example 2, and we want to classify X, Y, Z. So again, X, Y, Z, this is the whole entire triangle. And there's some other triangles in here, and they give you different things. So you kind of have to look and compare, and you go, well, the different angles in X, Y, Z, there's angle X, this one, and then there's this one here, and then there's this one here. Okay, so that's 50, this is 40, and this one, well, it told us that part's 40 and this is 50, so what you have to do is look at this and say, hey, together, that's 90 degrees, and so this whole angle together would be 90 degrees, and so that would be a right triangle. Okay, it's because X, Y, W, and W, Y, Z together make 90. Okay? All right. So the other way that we can classify triangles are by their sides, okay? So what we just talked about was by their angles, and now by their sides. Well, let's again start over on the right here. A scalene triangle is if none of the sides are congruent. And so remember how we marked if sides were congruent with the little hash marks in here? So none of those are marked as being the same, so we can assume they're all different. That's called scalene, no congruent sides. Secondly is isosceles. Isosceles, which is a really fun word to say, isosceles. Two sides, well, the way we normally think about this is that two sides are congruent, and that's how they have it marked here. Technically, isosceles means at least two are congruent. So theoretically, you could have one that's the two sides are congruent and the third one's congruent as well. But again, we want to be more, usually we want to try to be more precise. And so if in our for what we talk about, if all three are congruent, we're going to go ahead and call that equilateral, even though kind of a technicality is it does count as isosceles as well. But we're going to call it equilateral because all three sides are congruent. So the way that we normally think of it is isosceles are two sides are congruent, and equilateral is three sides are congruent. Okay, let's look at a few examples here. All right, what about this one? The frame of this window design. Okay, here's that same window design again. We want to classify this time ABC. but by its sides this time. So here's ABC is this one right here, that triangle. All right, again, there's no measurements, but we have to go by what it looks like to us. So do any of those sides look like they're the same? Well, if you look closely, it looks to me like probably side AC and side BC are the same, and it looks like AB is slightly different. And so I would have to say it looks like two sides are congruent, and so that would be isosceles. Bouncing red ball, isosceles. All right, there we go, isosceles. All right, so again, we've got a more complicated situation here, and so we have some things we got to figure out. All right, so it says point Y is the midpoint of Vx. So here's Vx, Y is the midpoint. All right, what does that mean again when we have the midpoint of something? It means that if this is the midpoint, Y is the midpoint, then each of those two parts that get split up there are exactly the same. So we know that the whole Vx is 8.4, so that we know that Vy is what? 4.2 units. And we know that Yx is 4.2 as well. Okay, so that was the first piece of information. Y is the midpoint, so we knew 4.2 and 4.2. It also told us here that Wy is 3 units. So where's Wy? Wy is this one right here, which is 3 units. Okay, so classify triangle VWY. So VWY, that's this one right here. We'll look at the sides. 3, 4.2, 4.5. Are any of those the same? No. So since none of these are the same, we would call this scalene. Okay, scalene triangle, because none of them are the same. All right, how about this one? Again, let's see, point C is the midpoint of BD. So if the whole thing is 3.4, we know this is what, 1.7, and that's 1.7. So we'll write that in there. Classify ABC. So ABC is this one right here. Well, you got 1.2, 1.7. Whoa, well, what's this one over here? Well, remember the little mark, the slash mark here? So that means that these are the same. So that means this is also 1.2. And so therefore, what, we have two sides that are the same? And so therefore, that would be isosceles, B. By the way, if they would have asked us for ACD, that would have been scalene, because 1.2, 1.7, and 2.5. Okay? All right, just a couple more. We're almost done. Again, as always, we want to be able to use this information to help us solve some problems and find missing values and so forth. All right, so here's what they've given us here. Find the measures of the sides. Oh, here, this is important. It tells us that we have an isosceles triangle with the base KL. Okay, let me mention this here then. So when you're talking about an isosceles triangle, the base, when they give you the base, that's the side that's not congruent, okay? So in this situation, so since KL is the base, that's this side here, if KL is the base, that means that KM and LM are congruent, okay? Does everybody, you get that? The base is the side that's not congruent. The other two sides are congruent. So when they tell you the base is KL, that means the other two are congruent. Okay, so what can we do to help find the measures of these sides? Well, if we know that these two sides are congruent, what kind of an equation could we set up? We're just going to set up an equation again, like we've been doing. Well, these have to equal each other, right? So 4D minus 13 has to equal 12 minus D. That's our equation, because they're congruent. And so then I'm just going to go plus D plus 13 plus 13. So 5D equals 25. Divide by 5. So D equals 5. Yay. Oh, but wait. Weren't we supposed to find the measures of the sides? Okay, well, what do we need to do then? Just plug it back in to each side to find out. So if D is 5, 5 plus 6 is 11. Okay, so side KL is 11. Again, we plug 5 in over here, so 12 minus 5 is 7. So side LM is 7. What do you think side KM should be? If it's congruent to this, it better be 7, or else we mess something up. So if I plug 5 in here, 5 times 4 is 20. 20 minus 13 is 7. All right, we got it. All right, last one. In this situation, it tells us we have an equilateral triangle. Okay, this is my equilateral triangle, ABC. All right, AB, let's go ahead and write this stuff in here. AB is 6x minus 8. BC is 7 plus x. And AC is 13 minus x. Okay. All right, so what do we do here? It's an equilateral triangle, and here are the different sides. Well, remember, all I'm going to try to do is write an equation and solve this equation. All right, so what can I do? I got to write an equation. Well, think about this. If it's equilateral, doesn't that mean all sides are the same? Okay, yeah. But Mr. Anderson, which sides do I make equal to each other? Guess what? If they're all the same, you know what you can do? Make any side equal to any other side. Whatever you think is easier, make that the equation. So personally, if I look at this, I go, to me, the 6x minus 8 looks kind of hard down here. So, it's a little harder. 7 plus x looks really easy. 13 minus x looks pretty easy. Why don't we make these two equal to each other? Okay. So I'm going to say 13 minus x has to equal 7 plus x. Could I do 13 minus x equals 6x plus 8? Sure. Could I do 7 plus x equals 6x minus 8? Sure. Any of those should work. Just don't do all three of them. Only pick two, okay? Pick two out of the three sides to make equal to each other. And so then all you do is plus x and minus 7. So here I have 2x equals 6. Divide by 2. So x equals 3. Okay, so we found x, but it also said find also and the measure of each side. Well, they should all be the same. So again, if these don't all come out the same, then we know something's wrong. Well, if x is 3, plug it in here. 13 minus 3 is 10. Here's 3, plug it in. 7 plus 3 is 10. And down here, the really hard one, 6 times 3 is 18, minus 8 is, all right, we got it, 10, 10, 10. Okay, we got all the sides. Any questions on those? Okay, well, appreciate you being here. That's just a little bit about triangles. We'll do much more with triangles, but that's it for now. Thanks for being with me. I'll catch you next time. See you later. Bye.